You've seen it before, maybe in someone sleeping next to you, eyes closed, but moving, rapidly, as if watching something no one else can see. Something is happening inside that mind. A world is being constructed, complete with people, places, emotions, and stories, out of nothing but biology. We call it dreaming, but science calls it something far more interesting. And for most of human history, we had absolutely no idea where it came from. You wake up at 3 in the morning, heart pounding. You are somewhere completely vivid, a place you've never been, with people you've never met. And within 30 seconds, it's already fading. You try to hold on to it, but the harder you reach, the faster it slips away. By morning, it's gone entirely. But here's what's remarkable. While you were dreaming, your brain was running at near full capacity, constructing an entirely convincing reality from scratch every single night. So the question is, why? Where do dreams actually come from? What triggers them? What purpose do they serve? And why does the brain go to such extraordinary lengths to create them? As we explored in episode 2, REM sleep is when the brain becomes nearly as active as when you're fully awake. And it's during REM, rapid eye movement sleep, that the vast majority of vivid, story-like dreams occur. But it's not just about which areas are active, it's about which areas are deliberately switched off. During REM, the prefrontal cortex, the brain's logical, rational decision maker, goes largely quiet, which is why in dreams, nothing seems strange. Flying feels normal. Impossible things make sense. Meanwhile, the brain's emotional centers, the amygdala and limbic system, remain highly active. This is why dreams are so emotionally charged. Fear, joy, grief, love, all felt intensely, without the rational filter to question them. So how does the brain actually build a dream? It draws on memory, but not in a straightforward way. It pulls fragments, a face from 10 years ago, a street you walked past last week, a feeling you can't quite name, and assembles them into a narrative. The hippocampus, the brain's memory hub, plays a central role. It retrieves stored experiences and hands them to other brain regions that weave them together into scenes, characters, and stories. Think of it as the brain running its own film studio overnight, with no script, no budget, and no rules about what's physically possible. The result is sometimes mundane, sometimes terrifying, sometimes breathtakingly beautiful. The honest answer is, science still doesn't have a single definitive explanation, but there are 3 leading theories, each supported by real research. Theory 1. Emotional processing. Dreaming may allow the brain to re-experience difficult emotional memories, but with the stress hormone norepinephrine switched off during REM. The idea: you can revisit painful events without the full emotional charge, gradually reducing their psychological weight. This may be part of why sleep is so critical after trauma or intense stress. Theory 2. Memory consolidation and creative connection. During REM, the brain doesn't just replay memories, it cross-references them. It finds unexpected links between unrelated experiences, which may explain why people often wake from dreams with new ideas, sudden insights, or solutions to problems they couldn't crack while awake. Theory 3. Threat simulation. One influential theory suggests dreams, especially threatening or anxious ones, serve as a kind of mental rehearsal. The brain simulates dangerous or challenging scenarios so that if they were to occur in waking life, you'd have already processed the emotional response, a form of psychological preparation. These theories aren't mutually exclusive. Dreams may serve all three functions simultaneously, and possibly others that science hasn't fully uncovered yet. Almost everyone dreams, multiple times per night, but not everyone remembers. And this comes down to one thing: timing. If you wake up during or immediately after a REM cycle, the dream is still active in short-term memory, and you can recall it. But if you sleep through to the end of a full cycle, the memory transfer window closes before waking, and the dream is lost. This is why alarm clocks that interrupt REM often produce vivid dream recall, while waking naturally at cycle end often produces none. Much of what we know about dreams comes from decades of sleep lab research, waking participants at precise moments during REM and asking them to report what they experienced. These studies consistently show that the most vivid, narrative-rich dreams occur during the later REM cycles, those that dominate the final hours of sleep. Another reason why cutting sleep short is so costly. Neuroscientist Matthew Walker at UC Berkeley has described dreaming as a form of overnight therapy, where the brain processes emotional experiences in a neurochemical environment uniquely suited to healing. His research links REM sleep disruption to increased post-traumatic stress symptoms and emotional dysregulation. Studies on people with REM sleep disorders, where the brain fails to suppress body movement during dreams, have given researchers a rare window into what the dreaming brain actually does. Participants physically act out their dreams, revealing the motor programs the dreaming brain runs as if the dream were real. Across cultures and throughout recorded history, humans have dreamed. Ancient Egyptians kept dream journals. Greek philosophers theorized about their meaning. Modern neuroscience has moved the question from what does a dream mean to what is the brain doing when it creates one? And the answers are far more remarkable. So what does understanding dreams change in practice? Many people who study sleep science keep a simple dream journal, not to decode hidden meanings, but because the act of writing immediately upon waking trains the brain to bridge the gap between REM memory and conscious recall. Over time, dream recall tends to improve naturally. One of the most consistent findings: lying still for 30 to 60 seconds before moving dramatically increases the chance of retaining a dream. Movement signals the brain to shift out of dream retrieval mode almost instantly. And perhaps most importantly, protecting your final hours of sleep, when REM cycles are longest and most emotionally rich, means protecting the part of sleep where much of this processing happens. Understanding this, you can decide what your sleep schedule is actually worth. This content is for educational purposes only and does not replace professional medical advice. Let's bring it together. Dreams are not random noise. They are the brain actively at work, processing emotion, consolidating memory, and possibly rehearsing for challenges ahead. those flickering eyes you see in a sleeping person. That's a brain running one of the most complex and least understood processes in all of biology, every night, in every one of us. Right now, across the planet, billions of people are dreaming, each brain constructing its own private world. Science is only beginning to understand what's really happening in those worlds, and why it matters as much as anything else we do. In the next episode, we turn to one of the most powerful biological signals your body produces every single day: melatonin. How does it work? When does it kick in? And what happens when modern life disrupts it? That's episode 4 of Decoding Sleep.